The topic is the chain rule for functions of two variables with two independent variables. So what do we mean with independent variables? In our case, the two independent variables are u and v. See, u and v. Both x and y are functions of u and v. So the first thing we need to do for this problem, we need to find partial derivative of z with respect to u, and the formula is right here. So first, what do we need? We need 1 partial z with respect to x. So partial z with respect to x, that would be equal, this is my z, partial with respect to x of ex ln of y. I'm taking derivative with respect to x, so ln of y is constant, I can take it outside. Now partial with respect to x of ex, which is just ex times ln y. So the answer would be ex ln y. Now I'm not done. Just to make this easy, the easiest way, plug in the x now, because we're gonna need it twice. We're gonna need it for calculating partial z with respect to u and calculating partial z with respect to v. So this is gonna be equal to e to the x. X happens to be ln of all that. So ln of u sine v, right, e to the x, and then ln of y. Y is u sine v. Also e ln, this is the same thing as, we can simplify it more, e to the ln of something. Let me write it here. E ln of x is equal x. So in our case, it's going to e ln of that equal that. So u sine v times ln of u sine v. So we're going to call this 1. Now we need to do 2. 2 is partial x with respect to u. Partial x with respect to u is equal, doing this, so I need to use ln of u, I need to use this formula, so it's going to be u prime over u. U prime, the u is whatever inside the parentheses, so u prime means partial with respect to u of the inside over u. U happens to be u sine v. I mean, has nothing to do with that u. This means whatever is inside the parentheses. In our case, this is what we mean with that. So derivative of that over that. Alright, now this is going to be what? Since the u sine of v is constant, I can take it outside. So sine of v, partial of u with respect to u over u sine v, which is just 1. So it's sine v over u sine v. So I'm going to call this 2. We're almost done. We're going to do 3. Partial z with respect to y. Partial z with respect to y is equal partial with respect to y of ex ln y. Now ex is a constant, I can take it outside. So that would be partial with respect to y of ln of y. So I'm using this formula, so it's going to be 1 over y. So ex times 1 over y. Now I'm going to plug in my x, it's right here, and my y. So this is going to be equal to partial z with respect to y is equal ex, 1 over ex will be what? E to the ln of u sine v over y is u sine v. But I'm going to use this formula one more time to get this stuff between parentheses. So this will be u sine v over u sine v, which is just 1. Make sure I didn't make any mistake. Ex ln of y. Yep. Alright, so this is going to be number 3. Now number 4, let's call this 4, partial y with respect to u. Now this is going to be partial with respect to u, what is y? U sine v. Now sine v is a constant, I can take it outside. Partial with respect to u, partial with respect to u of u, which is just sine v, right? So this is 4. Now I'm done. All I need to do is rewrite everything down. Therefore, partial z with respect to x is equal 1 times 2. 1 is right there. So u sine v ln of u sine v, 1, times what? 2. 2 is right here. Sine v over u sine v, good, plus 3. 3 is just 1 times 4. 4 is just sine v. Now I can simplify this with that or cancel these. Now partial z with respect to x will be equal sine v ln, forget this sign, I'm just gonna rewrite it here. So sine v ln of u sine v plus sine v. Don't have to factor sine v. Alright, now let's do this problem, partial z with respect to v. So I'm right here, is a formula. Now the good thing is I already know what partial z with respect to x. Let me rewrite it down. I already found those. Again, this is going to be 1 times 2 plus 3 times 4. I already have the 1. Partial z with respect to x. I already did it previously. And that was u sine v. I have to do this one more time. ln of u sine v. What else? Partial z with respect to y, I already done it also. Partial z with respect to y, which is number 3, is 1. Right? So this is what we call 1 and 3, already done. All I need is 2, which is partial x with respect to v. In our case, is partial with respect to x, partial with respect to v of ln of u sine v. Now this is, I'm using again this formula, ln of u prime. Let me write it here. I'm using ln of u prime is u prime over u. So this would be partial with respect to v of u sine v over u sine v. Now this is going to be equal v, oh no, actually the u is constant, take it outside. Partial with respect to v of sine v over u sine v. Now partial with respect to v of sine is cosine, so u cosine of v over u sine v, which is cotangent of v. So this is number 2. Now last one, we need number 3. Partial z with we need 4, actually 3 we have. Partial y with respect to v is equal partial with respect to v of what is y? U sine v. Now again, u can take outside because it's a constant. Partial with respect to v of sine v, so it's a u, derivative of sine is cosine, so this is going to be 4. Now all I have to do is rewrite everything. Partial z with respect to x is going to be equal 1, which is here, times 2, where is 2? Right there, cotangent V, plus 3, which is just 1, times 4 u cosine of V. Let me see if I can rewrite this. Actually, the cotangent is cosine over sine. I should have left it that way, because when I multiply it by this sine, cosine, think of cotangent is cosine over sine. If I multiply it by sine, let me do it here so you can see what I'm talking about. Sine V times cosine V. This will go and you will have only cosine left. So therefore, partial z with respect to x is equal, like I said, multiplying, you'll have only cosine left. So it will be u cosine V ln of u sine V plus eu cosine of V. And that's it for this problem.